All right, now I'm going to write a little thing here that's going to hopefully help you to remember. All right, let's do f of x, and then let's say is equal to, and then let's just do square root, and let's just make up something, like a 3x plus a 12. All right, now in this first section, all right, but in, for the most part, all these, okay, we always find domain in the real number system. Okay, real number system. So domain, algebraic approach, let's put over here real number system. Okay, real number system. Which means if I'm going to only work in the real number system, that means I can't have any of those imaginary numbers. I can't have an I underneath the radical. All right, so for me to figure out what the domain is, my focus has to be on just the part that is underneath the radical. I don't care that it's a square root. I mean, I know it's a square root. I know I don't want to take the square root of a negative number. Okay, so what am I going to do? I'm going to take whatever is underneath the radical, just the 3x plus the 5, or 3x plus 12, all right, and then I'm going to set it greater than or equal to 0. So I'm going to write 3x plus 12 greater than or equal to 0, and then I'm going to solve that. And whatever I solve that for x, that's going to tell me what x has to be to ensure that what is underneath the radical is a positive number and could even be 0 because it's greater than or equal to 0. We can take square root of 0. Square root of 0 is 0. Not an imaginary number, so we're good there. Okay, so that's the process for finding the domain of a square root function. Okay, so let's do some examples here. Find the domain. They're going to want you to write it in interval notation, because we've been doing that in all of our problems so far this semester. Okay, so we'll try to squeeze on 3 here. All right, so let's say they do f of x is equal to square root of 9x minus 27. Okay, so the algebraic approach, you're going to focus on what is underneath the radical. So that 9x minus 27. All right, the only thing I'm going to do is I'm going to set it greater than or equal to 0. So I'm going to go 9x minus 27 greater than or equal to 0. Go solve that. It should be a relatively simple equation, inequality there to solve. 9x greater than or equal to, let's add 27 to both sides. It's going to put a positive 27 over there. Okay, then we're going to have x is, divide both sides by 9, greater than or equal to 3. All right, now that's what you're going to use to, if you need to, remember what we have done. We have come up with something like this, and then we've went to a picture on a number line to help us write our interval notation in for our domain. So the next thing I'm going to do is I'm going to go to that number line. I'm going to put a 3 just in the middle. Okay, x is greater than or equal to 3, means square bracket. All right, and then the question is, where are the numbers that are bigger than 3? Well, 4 is over here, 2 would be over here, so that means square bracket on the 3, and then all of these numbers are going to be what we're going to use in our domain. Positive infinity is down here on the right. So once you pictorially represent it on our number line, then it's really easy to say, okay, my domain, square bracket, 3 to infinity, curly bracket. But we want all domains in interval notation. Okay, so just, you got to memorize, take what's underneath that square root, greater than or equal to, not greater than. If you forget and do greater than 0, then you'll have a curvy bracket down here on the 3, which would then make it wrong. Okay. Now, do not always assume that the domains will look like a number with a positive infinity. Okay, because you've got to remember every rule you've ever learned, especially as far as inequalities go. Okay, so if I did a second example, because I'm going to try to let you do one on your own here, we'll come up with 3. Let's say f of x is equal to the square root of, on this one, let's go 6 minus 2x. All right, so basically it looks the same. Square root, something underneath. You're not going to know just by glancing at it that something funky might happen, might change our answer a little bit here. You're going to focus on what's underneath that radical. Just that. You're going to remove the square root sign. You're just going to have a 6 minus that 2x, and then greater than or equal to 0. And then again, we're just going to solve that inequality. Subtract 6 from both sides. That'll make 6 negative on the right-hand side. The 2 is also negative, so negative 2x greater than or equal to a negative 6. Now, when I divide by a negative 2, you remember the rule? When we divide by a negative 2 on the inequalities, what do we do to the symbol? We take that symbol and we flip it. Okay? So, any rule you have previously learned on how to solve stuff, you got to keep doing that. So now this becomes x less than or equal to negative divided by negative gives me a positive 3. All right, so the inequality symbol just got flipped. That's why I'm saying your domains will not always look like a square bracket, a number, and then to positive infinity. Because if I do the same process and I put this on a number line, I put my 3 there in the middle, we know 4 would be over here, we know 2 would be over here. All right, greater than or equal to, I'm going to have a square bracket, but if I read this left to right, x is less than or equal to 3. So where are the numbers that are less than? That would be going this way, all the way out to negative infinity, and then the square bracket. All right, so see, I've got negative infinity coming all the way up to 3. So on the number line, you think left to right when you write your domain. So the domain is going to be negative infinity with the curvy bracket. That comes first, all the way up to the 3 with a square bracket. Okay, so either one of these are possible. I can start with a number and go to infinity. I can start at negative infinity and go up to a number. But for the most part, they're all going to look very, very similar to that. All right, I'm going to give you one more. I'm going to let you try it on your own. F of x is equal to, let's go with a 3 square root of 3x plus a 15. Shouldn't take very long, so we'll pause just a moment. Okay, hopefully you started with a 3x plus a 15 greater than or equal to 0. You subtracted 15 from both sides, 3x greater than or equal to negative 15. You divided both sides by 3. No flipping on this one because the number in front of the x is not negative. So x is greater than or equal to a negative 5. Okay, so you used that, and then you probably went to a number line, hopefully. You had a negative 5 here in the middle. That means a negative 4 would be on the right, a negative 6 would be on the left. It is going to be a square bracket. X is greater than or equal to negative 5. Numbers that are bigger than negative 5 would be to the right. Equals to sign part makes that a square bracket. Numbers that are bigger are going this way. Positive infinity is all the way down there. So then that means domain for this one would have been square bracket, -5, all the way up to positive infinity with a curly bracket. So the concept of how to do it is not hard, like the math's not hard. It's the, oh, I got to remember the process when you go to do it on a test. Okay, so being able to remember that process.